The first thing we're asked to do in this problem is calculate the molarity of nitrogen gas in the blood at 1 atmosphere and 4 atmospheres. So we use Henry's gas law to find the concentration of dissolved gas in moles per liter at 1 atmosphere and 4 atmosphere. So here's our equation. We know that the constant for nitrogen gas is 3.8 times 10 to the negative 4th. Now we plug in our atmospheres, so 1 and 4. And then when you do that for each 1 and 4 atmospheres, you get these concentrations. So these are the concentrations of nitrogen gas in moles per liter. Great. So then we're trying to find the volume of nitrogen gas released from 5 liters of blood. We know that these values are in moles per 1 liter, and we have 5 liters. So we just multiply both of these numbers by 5. And that gives us at 1 atmosphere and at 4 atmospheres how many moles of nitrogen gas is released. So we have at 1 atmosphere we have 0.0019 moles, and at 4 atmospheres we have 0.0076 moles. We're finding the volume of nitrogen gas released from 5 liters of blood, so we take our value from 4 atmospheres and then subtract the value from 1 atmosphere. So we take these values over here that we found and we subtract them, so 0.0076 moles of nitrogen gas minus 0.0019 moles of nitrogen gas. That gives you how many moles of nitrogen is released from 5 liters of blood. We want to turn the moles into liters. We're going to use PV equals nRT. So we plug in everything that we know. So we have 1 atmosphere times the volume, which is what we're trying to find. And we have our moles from over here. So 0.0057 moles of nitrogen gas times the gas constant, 0.0821 liters times atmospheres over moles per Kelvin, times our temperature, which is 310.15 Kelvin. So we know that our volume, our total volume of nitrogen gas that was released is 0.1451 liters. We want to know how many bubbles fit into that. So we find the volume of one bubble, and then once we know the volume of one bubble, we'll be able to figure out how many of those little bubbles fit in our bigger mass of nitrogen gas. So we use the volume of the sphere, which is 4/3 pi r cubed. We know that the diameter of one bubble is 1 millimeter, so the radius is 0.5 millimeters. So we plug that in, so we have 4/3 pi times 0.5 millimeters cubed. Then we get our volume in 0.5 in millimeters cubed, and we get 0.5235 millimeters cubed, but we don't want our volume in millimeters cubed, we want it in liters cubed so that we can more easily compare these two values. So then you convert this millimeters cubed value to liters through stoichiometry, and then we get the volume of one bubble, which is 5.24 times 10 to the negative 7 liters. So we know that's one bubble. We know this is our total amount of nitrogen gas that was released. So we take the total volume of nitrogen gas, which is this, divided by the volume of one bubble, which is this. That gives us the number of bubbles in the volume of nitrogen gas that was released, which is this. So you take those values, you plug them in, and then you get, I guess I'll go through it properly, 0.1451 liters of nitrogen gas divided by 5.24 times 10 to the negative 7 liters of nitrogen. Yes, like one bubble. Anyways, is 276,908 bubbles. So we know that we have 276,908 bubbles in 0.1451 liters. And if you wanted the bubbles per liter, if you wanted it in bubbles per liter per 1 liter, we know that 0.1451 liters times 6.89 equals 1 liter. So we know that we could just multiply this value times 6.89, and that would give us the bubbles in 1 liter, which is 1,908,394.